morning students, I welcome you all in this lecture. Today I am going to discuss the extrema, that means maxima and minima of function of two variables. Now let us draw the rectangular box. So this is your two sides. Suppose that this is your rectangular box, this is its front face and that is your back one. Now if P is any point on the surface of this rectangular box, let our solution, let x, y and z are the sides of the rectangular box. That means we can say that let x, y, z are the length, breadth and height of the rectangular box. Then now here you can see that if this is, suppose that your length is x, say your breadth is y and say height is z. Now as the box is rectangular, so the area of this base will be your xy, and now as the top of the box is open, so we have the surface area. Now if x, y, z are the length, breadth and height of the rectangular box, then it is given that it has a given capacity. That means your volume of the rectangular box is constant, say B. So it is given. Now we have to maximize or minimize. We have to find out the dimension of a rectangular box for which we need the least material. So that means we have to minimize your surface area. Now as the top of the box is open, so your surface area will be xy. Now this is your y and this is your z. So the area of this part will be yz, again the area of this part will be yz, and your x, this is your x, again this will be your x, so area of this part will be zx and area of its back part will be zx. So the surface area will be xy plus 2yz plus 2zx. This is when your top of the box is open. Now if the top of the box is closed, then again we will have 2 times xy. Now we have to minimize this surface area, and for that we need to find out this dimension of the, we have to find out the dimensions of the rectangular box. Now here we can put the value of z from here, so your z will be b upon xy. So we have b upon xy here, so this is equal to xy plus, here we will have 2b upon x plus 2b upon y. So your del s upon del x will be y minus 2b upon x square. Your del s upon del y will be x minus del b upon del y square. Del 2s upon del x2 will be 4 times b upon x cube, and del 2s upon del y2 will be, this is your 2 times v. So this will be your, and this is your y square. So this will be your 4 times v upon y cube, and del 2b upon del x del y will be equal to del 2s upon del x del y will be equal to, and let us differentiate this one with respect to y. So on differentiating this one with respect to y or this one with respect to x, we will have 1. So now for maxima and minima, our del s upon del x will be 0 and del s upon del y will be 0. So we have y minus 2b upon x square equal to 0 and x minus 2b upon y square equal to 0. So from here we have b equal to, so your 2b upon your b will be x square y upon 2, and from here our b will be y square x upon 2. So we can say that this is equal to x square y upon 2 equal to y square upon x, y square into x upon 2. So from here we will have x equal to y, because one x will get cancelled and y will be cancelled. So we have x equal to y. Now if x equal to y, then from here we can have the value of v. We can have the value of x or y. So as because our b equal to x square y upon 2, so put the value of y as x, so we will have x cube upon 2. So your x will be 2b power 1 by 3. So because your y is x, so our y will be 2b power 1 by 3. So we have the values of x and y, where v is constant, it is fixed because it is given. Now let us compute r. R means del 2 s upon del x2 at x comma y. So this is equal to, your del 2 s upon del x2 will be 4b upon x cube. X cube means your x cube will be 2b. So this is your, this means this is your 2. So del 2 s upon del x2 will be 4b upon x cube, and x cube will be just 2b. So we have this one as 2. Your s is equal to 1 and t is equal to 4b upon y cube, and this is again 2. So therefore rt minus s square is equal to 4 minus 1, so this is your 3, which is positive, and r equal to 2, which is again positive. Therefore at x comma y we have minimum. So for these values of x and y, we require the least material for the construction of the rectangular box, which has a given capacity. So the dimensions are 2b power 1 by 3 and 2b power 1 by 3, where b is the capacity of the box. Then the next question, show that the rectangular solid of maximum volume that can be inscribed in a sphere is of cube. The equation of the sphere is x square plus y square plus z square equal to a square, where a is the radius of the sphere, and let P be any point on this sphere. So we have the question of the type. Suppose that this is your sphere and this is your rectangular solid, Now, if this is your origin, then this is your radius, which is your A. So this point is x, y, z. So this is your x, y, z, and this is your origin. So we can say that our A square is equal to x square plus y square plus z square, because this is your radius. Now, if this is your x, then we can say this is our x. So this is your x. So the one side of the rectangular box is 2x. So if this is your 2x, if this length is 2x, then we can say that our height will be, this is your y, again this is your y, so this will be your 2y. So length is 2x, y is, your breadth is 2y, and similarly our height is 2y, and similarly we can say that our breadth is 2z. So hence the volume of rectangular solid is B equal to 2x into 2y into 2z. So this is equal to 8xyz. Now we have to maximize our volume for this given condition. So our B square will be 8, that is 64 x square y square z square. Let us put the value of z square from here in this equation and assume B square as u. Now we maximize our u, which is our B square, equal to 64 x square y square, and then the value of z square will be a square minus x square minus y square, where my B square is u and we have this value of z square. So for maxima and minima, now let us send this value inside this bracket. So we have a square x square y square, then we will have x power 4 y square, then x square y power 4. So for maxima and minima, our del u upon del x is 0 and del u upon del y equal to 0. We can also solve this question with the help of the Lagrange multiply method, and that is very easy. So in this case, let us solve this with the help of the two variable method. So for maxima and minima, your del u upon del x equal to 0 and del u upon del y equal to 0. So from here we will have 64. Now the differences in respect to x will be a square, then we will have 2x into y square. So from here we will have 4x cube into y square, then we will have 2x into y power 4. So this is equal to 0 and 64. Then the differentiation with respect to y. So we will have a square 2y into x square, then 2y into x power 4, then we will have 4 into x square y cube. So this is equation number 1, this is equation number 2. Now if we take x y square common, then we have x y square, then in the bracket let us take 2 common. So in the bracket we will have just a square. We have already taken 2xy square common, so here we will get 4x square, sorry 2x square, and here we will have, we have taken 2xy square common, so we will have y square. This is equal to 0, and here we will have 64, we have removed 64, so here we will have 2yx square, then in the bracket we will have a square minus x power 2 minus 2y square. So now from here either our x and y will be 0, or so from here we have 0 comma 0, x equal to 0 and y equal to 0, and the other points will be 2x square plus y square equal to a square, and x square plus 2y square equal to a square. So if we multiply this equation by 2 square, on solving, let us multiply this equation by 2, so we will get 4y square minus y square, so 3y square, Now this will be a 2a square minus a square will be a square. So our y is equal to a upon root 3. So if your y is a upon root 3, then our x will be a square minus 2y square. So this is equal to a square minus 2. Your y square will be a square by 3. So this is your 3a square minus 2a square. That means a square by 3. So our x is a upon root 3. So our x is therefore 0, 0 and a upon root 3, a upon root 3 are two possible stationary points. And we can now find out the value of z. So this is your one point, and for 0, 0, so 0, 0 and a by root 3, a by root 3 are stationary points. So these are our stationary points. Now, with the help of these stationary points, let us calculate del 2 upon del x2 and del 2 upon del y2 and del 2 upon del x del y. That means r, s and t. So now del 2 upon del x2 will be equal to, now the double differentiation with respect to x will be 64 a square. Now the double differentiation with respect to x will be 2 a square y square. Then here we will have 12 x square y square. Then we will have 2 y power 4. And del 2 upon del y2 will be 64 2 a square x square minus 2 x power 4 minus we will have 12 x square y square. So these are the values of del 2 upon del x2 and del 2 upon del y2, and then del 2 upon del x del y. Now if we differentiate this equation with respect to y, then we will have 64 into a square. Now this will be a 4 a square into 4 xy. Now this will be your 8 x cube y, and this is your minus 8 x y cube. So we have the double values of the double derivatives. Therefore your r at a upon root 3 comma a upon root 3 is equal to, now just put the value of x and y. Now here we can see that our x and y are equal to each other. So if you want to take common, then we can write it as 64 to a square, y is your a upon root 3. So this will be your a square upon 3. Now this is your 12 a square upon 3 into a square upon 3. Then we will have 2 into power 4 will be a power 4 upon 9. So this is equal to 64 into 2a4 upon 3 minus 12 a4 upon 9 minus 2 a4 upon 9. So this is the value of r, and you can see that this will be your 6, then we have minus 12 minus 2. So this is your negative. Now this r is negative, and this is equal to 64 into, now this will be your 6 a power 4 minus 12 a power 4 minus 2 a power 4 divided by 9. So this is equal to 64 into minus a 4 upon 9. So we have this one equal to, so this is equal to minus into, this will be a 2 5 upon 12 divided by 9 into a power 4. So this is our r. So similarly our t will be Similarly, as x and y are symmetrical to each other, so our t will be same value, that means minus 512 upon 9 into a power 4, and your s will be 64. Then we have a square into 4 into x, a by root 3 into a by root 3, so this will be a square by 3. Then we will have 8x cube. X cube will be a cube upon 3 root 3 into the value of y. Y is a upon root 3, so this will be your a power 4 upon 9. Then we have 8 a power 4 upon 9. So this is equal to 64. Now 12a power 4 minus this will be 16 a power 4 divided by 9, and this is your minus 4. So this is equal to 256.9 a power 4. Again, this is your negative. So therefore your RT minus S square is equal to R into T. So 5.12 into 9 a power 4, and again your T is this one, so this will be your whole square of this one minus S square, 256.9 a power 4. So we can say that this is your positive. So your RT minus S square is positive and R is negative. So at a upon root 3, comma a upon root 3, we have minimum. We have maximum. So we have maximum at this point. And let us find out the third side of the z. So z is equal to a square minus x square minus y square. So this is equal to a square. Your x is a upon 3, a square upon 3, y is a square upon 3. So this is equal to 3a square minus 2a square, so a square upon 3. So therefore your z equal to a square a upon 3. So because our x, y equal to z, as our x and y and z are equal to each other, so we can say that therefore your rectangular solid is a cube with maximum volume and which can be inscribed in a circle, in a sphere. So rectangular solid of maximum volume that can be inscribed in a sphere is your cube.